In this video, we'll start solving exercise 7.1 from your chapter Integrals in your NCERT textbook. And this is the only video you need to master this exercise. Let's get started. All right, let's look at question number 6 from your exercise 7.1, which is integral of 4e to the power 3x plus 1 with respect to x. Now, since there is addition in between, we can just split the integration between the two terms. So we get I equals integral of 4e to the power 3x dx plus integral of, now you give that integral to 1. So integral of 1 dx. So you split the integral between the first term and the second term. Now also this 4 is in product or multiplication. You can just take the 4 out of integral. So you get 4 integral of e to the power 3x dx plus integral of 1 dx. So basically now there are two integrals that we want to find out, which is integral of e to the power 3x and integral of 1. Okay, let's look at each of those individually. Now let's look at first e to the power 3x. We know that integral of e to the power x dx is nothing but e to the power x. However, we have also studied a property of integral in the previous video that if instead of x, if you have a linear term, if you have e to the power ax plus b dx, if you have a linear term instead of x, if you have ax plus b, the integral would become e to the power ax plus b. So the same formula can still be applied if integral of e to the power x is e to the power x. Integral of e to the power ax plus b is also e to the power ax plus b. However, you just divide by coefficient of x. So you just divide by coefficient of x. Okay. So we can do the same thing here as well. So if it was e to the power 3x dx, like we have here, the integral would become e to the power 3x divided by 3. So the same formula can be applied, but you just have to divide by coefficient of x. Okay. So now let's look at integral of 1 dx. We know 1 can be written as x to the power 0. So since 1 is x to the power 0 and we know integral of x to the power n dx is x to the power n plus 1 over n plus 1. So which will give you integral of x to the power 0 dx equals x to the power 0 plus 1, which is 1 over 0 plus 1, which is 1, which is x. Okay, so integral of 1 is nothing but x. You have to remember this actually from next time, that you can just say that integral of 1 dx is nothing but x. That's just remember this from next time. Okay, so now let's substitute those terms, apply those concepts here. So we get equals 4 times integral of e to the power 3x is e to the power 3x divided by 3 plus integral of 1 dx is nothing but x. And let's add a constant term c since we are done integrating. Okay, so that's your result. All right, now let's get started with question number 7. It says integral of x squared times 1 minus 1 over x squared dx. Now, since I see a product here, generally in integration, if you see a product, you try to convert it to either addition or subtraction, just because it's easy to integrate addition or subtractions rather than integrating a product. It is possible to integrate a product that we'll see in the later part of this playlist, but it's generally easy to integrate addition or subtraction. Okay, now let's see if we can convert this to addition or subtraction by multiplying this term inside. So that would become integral of, just multiply this inside, x squared times 1 is x squared minus x squared times 1 over x squared is 1, because that x squared and x squared will get cancelled, and with respect to x. Now, since it's subtraction in between, just give the integration to both the terms. So you get integration of x squared dx minus integration of 1 dx. Okay, now we can integrate it easily. We get integral of x squared. We know it's like x to the power n. The integration is x to the power 3 over 3 minus integration of 1 is x plus c. Now that's your integral. All right, now let's do question number 8. Integral of ax squared plus bx plus c. It's since it's a product in between, you can just split the integration in those terms. So you get integral of ax squared dx plus integral of bx dx plus integral of c dx. Okay, so you split the integral between those three terms. Then you can take these constant terms out easily. So this a is a constant, so you can take it out. So you get a integral of x squared dx plus take that b out. So b integral of x dx plus take that c out. So c integral of 1 dx. Remember that there is 1 left here when you take c, not 0. Okay. Now you get a integral of x squared. We can just do like x to the power n, which is x to the power n plus 1, which is 2 plus 1, 3 over 3 plus b. This x is like x to the power 1, so the integral is x squared by 2 plus c. Now integral of 1 is x. Add a constant term c since you are done integrating. Now remember that there is c already. So instead of writing the constant term as c, just write it as c dash, just to differentiate between the existing variable c and that arbitrary constant c. Okay, so that's your solution. Okay, hope that makes sense. All right, let's move on to question number 9. Integral of 2x squared plus e to the power x. Now, since it's addition, let's again split the integration in both the terms. So you get integration of 2x squared dx plus integration of e to the power x dx. All right. Now, since it's 2 is constant, you can take it out. So you get 2 integration of x squared dx plus integral of e to the power x dx. Okay. Now you can write 2. Uh, Integration of x squared is x cubed by 3 plus, we know integral of x squared, sorry, integral of e to the power x is integral of e to the power x plus the constant c. That's your result. I hope that makes sense. All right, now let's move to question number 10, which is integral of root x minus 1 over root x the whole squared. Now, whenever it's not a simple addition or subtraction, here there is a whole squared. In integral, you have to always try to simplify using some algebraic or trigonometric simplification technique. Okay. In this case, since it's a whole square, you can simply apply a minus b the whole squared. The result of a minus b the whole squared, which is a squared minus 2ab plus b squared. So let's say this is equals integral of, let's apply the whole squared. So a squared, so that is root x squared minus 2ab. So root x times 1 over root x plus b squared. So 1 over root x the whole squared. Okay. Now we can write it as root x squared is nothing but x minus. Now this root x and this root x will get cancelled. So you get 2 plus 1 over root x the whole squared is nothing but 1 over x. I'll put a bracket and I'll say dx and also dx here. Okay, now it's simple addition and subtraction. So you can just give the integral to each of those terms. So you get integral of x dx minus integral of 2 dx. So give integral to x, then give integral to 2 plus integral of 1 over x dx. Okay, so give out that integral to each of those terms. Then you get integral of x, which is x to the power 2 over 2 minus this 2 can be taken out and you are left with 1. An integral of 1 is x plus, now remember that integral of 1 over x is log mod x from the initial formula discussion that we had. Okay, and add a constant c. That's your result for the integral. Okay, I hope that makes sense. All right, now let's do question number 11. it says integral of x cubed plus 5x squared minus 4 divided by x squared. Now remember that there is a division here. We cannot directly integrate a division. There is no division rule in integration as such. So whenever in integration you have a term which you cannot integrate, always the general rule is you apply some algebraic or trigonometric simplification technique. In this case, you can just simply split this x squared in all the terms. To simplify this, split this x squared in all the terms. So it will look like equals x squared, sorry, x cubed over x squared plus 5x squared over x squared minus 4 over x squared dx. Okay, so you split that x squared into all the three terms, then you get x cubed over x squared is x plus this x squared and x squared will get cancelled, so you'll be left with 5 minus 4 over x squared dx. Okay, now you can integrate, give the integration to each of those terms. So you get integration of x dx plus integration of that 5 dx minus integration of 4 over x squared dx. Give the integral to each of those terms. Then you get, so this x, the integral of x is x squared by 2 plus, take this 5 out, integral of 1 is x as we discussed, minus, take that 4 out and you are left with 1 over x squared. Now remember, integral of x to the power n is x to the power n plus 1 over n plus 1. Now since it is 1 over x squared, you can actually write it as x to the power minus 2. That 1 over x squared can be written as x to the power minus 2 dx. Okay, so I keep all these terms same. So I get x squared by 2 plus 5x minus 4. X to the power minus 2 is x to the power minus 2 plus 1 over minus 2 plus 1. Okay, so that will give me x squared by 2 plus 5x. Oh, also I should add a constant c since I am done integrating here. Minus 4 minus 2 plus 1 is minus 1. Okay, so I get minus 1. Minus 2 plus 1 is again minus 1. So x to the power minus 1. This minus and this minus will become positive. Okay, and that x to the power minus 1 is nothing but 1 over x. So you are left with x squared by 2 plus 5x plus 4, and then this x to the power minus 1 is over x plus that constant c. That's my result of the integral. All right, now let's look at question number 12. There is again a division here. So we'll use the same technique. We'll split this square root of x in all the three terms. So you get integral of x cube over square root of x plus 3x over square root of x plus 4 over square root of x dx. Okay, next, now this is x to the power 3 and this square root of x is nothing but x to the power half. Okay, so remember this square root of x is x to the power half. Okay, even here the square root of x is x to the power half. Okay, now you can apply the law of indices here. Since this is 3, since this is x to the power 3 and in the denominator you have x to the power half, so that will become x to the power 3 minus half, because since the base is same you can subtract those powers, so you will be left with x to the power 3 minus half will become 5 by 2. Okay, so 6 minus 1, 5 by 2. Okay, now let's see this one, x to the power 1 divided by x to the power half. So that will become x to the power 1 minus half. Can subtract those powers since it's a division. Now that would be x to the power 1 minus half is half. Okay. And this is 1 over x to the power half. So that's nothing but you can take this in the numerator and that will become x to the power minus half. Okay. Now we can substitute those terms in the integral that we found out. I hope that makes sense. You use the laws of indices to subtract those powers because it's a division. Okay. So you are left with the first term is x to the power 5 by 2, x to the power 5 by 2 plus 3x to the power, the second term is x to the power half plus 4, and the third term is x to the power minus half, x to the power minus half dx. Okay, I hope that makes sense. Now split the integral in each of those terms. So you get integral of x to the power 5 by 2 dx plus integral 3x to the power half dx plus integral 4x to the power minus half dx. Okay, just split the integral into all those terms. You can simply apply now the formula x to the power n. X to the power n is x to the power n plus 1 over n plus 1 plus, take that 3 out of the integral, you're left with x to the power half. So it is half plus 1 over half plus 1 plus, take that 4 out, you are left with x to the power minus half plus 1 over minus half plus 1. So you basically apply the formula for integral, which is x to the power n. Now just do basic simplification. Now that will become x to the power 5 by 2 plus 1. 5 by 2 plus 1 is nothing but 7 by 2. Okay, because you can just say 5 plus this 2, divide by 2. Divide by 7 by 2 plus 3, x to the power half plus 1 is 3 by 2 over 3 by 2 plus 4, x to the power 1 minus half, or minus half plus 1 is nothing but plus half over half. Okay. Now that 2 is in the denominator of the denominator. So that can be taken in the numerator. So that will become 2 over 7 x to the power 7 by 2. Since that 2 is in denominator of the denominator, that will come in the numerator. Plus that 2 also denominator's denominator, that will come in the numerator, and that will become 6 with this 3. So 6 by 3 x to the power 3 by 2. Again that 2 will come up and become 8 x to the power 1 by 2. You can add the constant c. In fact, you can just add it here when you are done integrating. Add the constant c. That's it. All right, let's look at question number 13. It's again a division here. There is again no division rule in integration. So you have to do some kind of algebraic simplification. If you notice, this is a polynomial over polynomial. In such a case, generally we, since the power of the numerator is greater than denominator, we do actual division technique. We will study that in the next video. But in this case, this is a special case where you can just simplify using a very simple observation. So if you just see this x cube and x squared, between those two terms, you can take x squared common. So you will be left with x minus 1. Okay, so if you, between those two terms, if you take x squared common, you are left with x. In this x cube, you are left with x, and in this x squared, you are left with 1 plus x minus 1 and divide by x minus 1 dx. Now in the numerator, you can again take that x minus 1 term common between those two terms. So you are left with integral of x minus 1 So you take that x minus 1 common, you are left with x squared plus the term 1 here. Okay, so x squared plus 1 over x minus 1 dx. Okay, I hope that makes sense. You take x minus 1 common from those two terms. So you're left with x minus 1 and x squared plus 1. Now, if you notice, this will get cancelled. X minus 1 and x minus 1 will get cancelled, and you are left with integral of x squared plus 1 dx, which is equals. Now, just split the integration in those two. Get x squared dx, integral of x squared dx plus integral of 1 dx. Okay. Now, that will turn out to be integral of x squared is x cubed by 3 plus integral of 1 dx is x plus add a constant term c, and that's your result. Okay, so since it was there was this basic simplification possible, we just took that x squared common and this term turned out to be same. If this was not the case, this was of the type polynomial over polynomial, px over qx, because if you see in the numerator is a polynomial, denominator is a polynomial. Since it was a type polynomial over polynomial and power of the numerator, which is px, was greater than power of qx, which is the denominator. Since the power of numerator is greater than power of denominator, generally we would do actual division method. Actual division method. But in this case, it was not required because a simple observation, we noticed that this x minus 1 was the common term. Okay, but if this was not the case, this is the method we do, which is actual division, which we'll study in our next video. All right, question number 14th. Integral of 1 minus x times root x. Since it's a multiplication, you can convert it to subtraction and addition by simply multiplying this root x inside. So you get integral of 1 times root x is root x minus x times root x dx. Okay. Now here in this second term, which is x times root x, if you notice, this is x times 1 times x times half, because the square root of x is nothing but x times half, right? Now, since the base is same in those two terms and it's a multiplication, you can add those powers. So you get x to the power 1 plus half. Okay, if the base is same, you can add those powers. So you get x to the power 1 plus half, which is 2 plus 1, 3 by 2. 1 plus half is 3 by 2. Okay, so x to the power 3 by 2. So basically this x root x is nothing but x to the power 3 by 2. Okay, now let's split those integral in those two terms. So the first integral is root x dx minus integral. So give out integration to both the terms. First integral is root x dx minus integral. The second term is x to the power 3 by 2 dx. Also, we can just write this square root of x as x to the power half. Okay. Now, if you try to integrate, you can just simply apply x to the power n formula, and you get, we know integral of x to the power n is x to the power n plus 1 over n plus 1 minus x to the power 3 by 2, again same formula, x to the power 3 by 2 plus 1 over 3 by 2 plus 1. Okay, and plus c constant. Since you are done integrating, we can simplify this a little bit just by saying half plus 1, and half plus 1 is 3 by 2 over 3 by 2 minus 3 by 2 plus 1, 3 plus 2. So that's nothing but x to the power 5 by 2 and 5 by 2 plus c. Okay, now that 2 here is again in the denominator's denominator. A denominator's denominator goes in numerator, so that 2 can go in numerator and become 2 x to the power 3 by 2 over 3. Okay, that 2 can be taken in the numerator, so you get 2 x to the power 3 by 2 over 3 minus, again that 2 can go in the numerator, so 2 x to the power 5 by 2, this term, divide by 5 plus the constant of integration c. That's your result of integral. I hope that makes sense. All right, let's look at question number 15th. It's again a multiplication. So you can simply multiply that root x inside the bracket and you get integral of root x times 3x squared, let's put a bracket, plus root x times 2x, root x times 2x, plus root x times 3 and dx. Okay, so you multiply that root x and give it to those three terms. Okay, now also split the integral into those now converted additions. So you get integral of, give those integral to each of those terms. So you get 3 root x x squared dx, that's the first term, plus, so the first term is 3 root x and x squared dx, plus second term is 2 root x times x dx. Okay, that's the second integral, 2 root x and x, plus integral, the third term is 3 root x dx. Now you can take the constant terms out of those integral. Also, if you observe carefully, you can again apply the law of indices here. Generally in integral, it's either algebraic or trigonometric simplification to make it simpler. Okay, so if you look at these two terms, we know root x is nothing but x to the power half, and this is x to the power 2. Since the base is same again, those powers will get added. So that will be x to the power half plus 2. That would become x to the power half plus 2 is nothing but 2 times 2 is 4. So 1 plus 4, which is 5 by 2. I hope that makes sense. It's just a law of indices. Even here, that term can be written as x to the power, root x is x to the power half times x to the power 1. Since again the base is same, you can add those powers. That will become x to the power half plus 1, half plus 1. That will become 1 plus 2, which is 3 by 2. So half plus 1 is 3 by 2. Okay. Now again, this is just square root of x, which is x to the power half. I hope those indices simplification makes sense. Okay. Since the base is same, we can just add those powers. And by adding the powers, here we get half plus 2 is 5 by 2. Because 1 plus that 4, which is 5 over this 2. Okay, and so on. So 1 plus 2 over 2, which is 3 by 2. Okay, now let's substitute those values in integral and you get, take that 3 or those constants out. So take that 3 out of integral. So you get 3 integral of x to the power 5 by 2 dx, plus take that 2 out. You're left with x to the power 3 by 2 dx, plus again take that 3 out. You are left with integral of x to the power 1 by 2 dx. Okay, that is equal to 3 integral of x to the power 5 by 2. Again, it's like x to the power n. So that will become x to the power 5 by 2 plus 1 over 5 by 2 plus 1, plus 2 x to the power 3 by 2 is x to the power 3 by 2 plus 1 over 3 by 2 plus 1 plus 3. Integral of x to the power 1 by 2 is x to the power 1 by 2 plus 1 over 1 by 2 plus 1. Okay. Now let's just do a little bit of simplification to make it look nice. 3. Now, 5 by 2 plus 1 is, you can just multiply that 2 here. So 5 plus 2, which is 7 by 2 over 7 by 2 plus 2 x to the power. Similarly, this will become 3 plus 2, which is 5 by 2 over 5 by 2 plus 3 x to the power half plus 1. So 1 plus 2 divided by 2, which is 3 by 2 over 3 by 2. Okay. Now let's just simplify a little bit. Also add constant of integration c here. Now that 2 is in the denominator's denominator, that will go in numerator. That 2 will go in the numerator and become 6 along with this 3. 3 times 2 divide by 7 you have already. X to the power 7 by 2 plus that 2 again can go in the numerator because it's denominator's denominator. That can go in the numerator. That will become 4 by 5 x to the power 5 by 2 plus again that 2 will become 6 along with this 3, or actually you can just cancel this 3 and this 3, so that 2 will go in the numerator and just become 2 x to the power 3 by 2 plus the constant c. That's your result of integral. I hope that makes sense. All right, let's move to question number 16th now. uh, it's just simple subtraction and addition terms. You can split the integral directly between those terms. So that will become integral of 2x dx, 2x, the first term, give the integral to the first term, minus integral of 3 cos x dx, give the integral to the second term, plus integral of e to the power x dx. Okay. Now take those constants out. Take that 2 out and you are left with 2 integral of x dx minus, take that 3 out and you are left with 3 integral of cos x dx plus, there is no constant here, so you just write integral of e to the power x dx. Now you can integrate those terms directly. So you are left with 2. Now integral of x to the power 1 is x to the power 2 over 2 by x to the power n. Formula of x to the power n, it's x to the power 2 over 2 minus 3. The integral of cos x is sin x, as we discussed in the formula video, plus integral of e to the power x is e to the power x. You can simply cancel out that 2 and add a constant of integration c, and that's your result of integral. All right, let's look at question number 17. It's again simple addition and subtraction. So you can again split the integral in those terms. So you get integral of 2x squared dx minus integral of, give the integral to 3 sin x. So 3 sin x dx. Now give the integral to this last term plus integral of 5 root x dx. Okay. Now take those constant terms out. From those integrals, take those constant terms out. So you are left with 2 integral of x squared dx minus, take that 3 out, 3 integral of sin x dx plus, take that 5 out, 5 integral of root x dx. Okay. Now it's very easy to integrate. You can just say 2 integral of x squared dx is x to the power 3 over 3, okay, minus 3 integral of sine x is minus cos x. So that will become minus cos x. Integral of sine x is minus cos x, as we discussed in the formula list, plus 5. By now we know this x to the power or square root of x is x to the power half. So the integral of x to the power half is x to the power half plus 1 over half plus 1 plus constant of integration c. Okay, just a simplifying little bit, you get 2x cube over 3. This minus and minus, negative and negative, will become positive 3 cos x, okay, plus, now this half plus 1 is 3 by 2. So 5 x to the power half plus 1 is 1 plus 2 divided by 2. So which is 3 by 2 over 3 by 2. Okay. Now again, that 2 is in denominator's denominator. That will go in the numerator. Let's also add the constant c. So 2x cubed by 3 plus 3 cos x plus, that 2 can go in the numerator. So it will become 10 by 3. That 2 will go in the numerator. So 5 times 2 is 10. Divide by this 3, x to the power 3 by 2 plus c. That's your result. All right. Now let's see the integral sec square x over cosec square x. Now in integral, we know we don't have a division rule. We always try to apply some kind of algebraic or trigonometric simplification to convert it into a form that can be integrated easily. Now here, since it's sec and cosec, I'll convert it to sine and cos. We know that 1 over sec x is cos x, and we also know 1 over cosec x is sine x. So we can convert that sec and cosec into sine and cos. The way we do that is we can just write this as sec square x multiplied by 1 over cosec square x. Okay, so that denominator cosec square x can be just written as 1 over cosec square x. Now we know integral. Now we know sec square x is nothing but 1 over cos square x. If we convert to sine and cos, we know sec square x is nothing but 1 over cos square x because they are reciprocals of each other. And this 1 over cosec square x is nothing but sine square x. Okay, and dx. Let's not forget dx. Okay, now this is nothing but integral of sine square x over cos square x dx. Now we know sine over cos is nothing but tan. So this will become tan square x dx. Okay, I hope that makes sense so far. Now we don't know the integral of tan square x. However, we do know the integral of sec square x dx, which is tan x. We don't know the integral of tan square x, but we know that integral of sec square x is tan x. So can we convert this tan square x into sec square x? Because we know the integral of sec square x. So it is best idea to convert that tan square x into sec square x. And how can we do that? We can use the identity. We know that 1 plus tan square x is nothing but sec square x. Therefore, we know that tan square x can be written as, take this 1 on this side, sec square x minus 1. So we can use the identity and say that tan square x is nothing but that sec square x minus 1. Therefore, this tan square x, we can convert it into sec square x like so. And we get sec square x minus 1 dx. I hope that makes sense. We didn't know the integration of tan square x, which is why we convert that tan square x into sec square x using the identity. Okay. So now split the integral in both the terms. So you get integral of sec square x dx minus integral of 1 dx. Give the integral to both the terms. And then you get the integral of sec square x. We know it is tan x from the formula, because also the derivative of tan x is sec square x. So we remember from the formula that integral of sec square x is nothing but tan x minus integral of 1 is nothing but x, plus add the constant of integration c, and that's my result, tan x minus x plus c. All right, let's look at question number 20. Again, there is a division here. We know in integration, whenever there is a term which cannot be directly integrated, we try to simplify it by some kind of algebraic or trigonometric simplification. So in this case, we can split this cos square x in both the terms. We can say integral of, give this cos square x to 2, so 2 divided by cos square x minus, give this cos square x to this 3 sin x. So 3 sin x over cos square x and with respect to x. Okay. Now split the integral between those two terms and we get integral of 2 over cos square x dx minus integral of this second term 3 sin x over cos square x dx. Okay. Now we know this 1 over cos square x or reciprocal of cos x. We know 1 over cos x is nothing but sec x. Okay. So this 2 over cos square x can be written as 2 sec square x, because we know the reciprocal of cos is sec. So this can be written as sec square x dx minus integral of 3. Now we know this cos square x can be written as cos x times cos x, just to simplify it further. Okay, let's simplify this further and say integral of 2 sec square x dx minus 3 integral of 3. This sin x over cos x can be written as tan x, and this reciprocal of cos x, 1 over cos x here again, can be again written as sec x dx. We forgot a dx here. Okay, that makes sense. So that sin x over cos x can be written as tan x. There is 1 over cos x that can be written as sec x. Okay, now we can take those constants out of the integral and we get 2 integral of sec square x dx minus, take that 3 out, 3 integral sec x times tan x dx. Okay, so take that 2 out, take that 3 out from this integral and we have this result. Now we know the integral of sec square x is nothing but tan x from the formula discussion minus 3, and integral of sec x into tan x is nothing but sec x. Now that we are done integrating, add a constant c, and that's your integral. All right, let's look at question number 21. It says antiderivative of this. Now, antiderivative we know is just integrals. As we discussed in the first video, antiderivative is nothing but integral. So basically what they are saying is find the integral I of that function, root x plus 1 over root x dx, because that antiderivative is nothing but an integral. Okay. Now we can simplify this using the laws of indices as we did in our few problems before. We know the square root of x is nothing but x to the power half, plus we know this 1 over square root of x is x to the power minus half dx by the laws of indices. Okay, now simply we can integrate this, or we can give the integral first to this both the terms. So we get integral of x to the power half dx plus integral of x to the power minus half dx. Okay, now you can simply apply the formula of x to the power n, which is x to the power n plus 1 over n plus 1 plus x to the power, again x to the power n, so minus half plus 1 over minus half plus 1, and plus add the constant c for the integral. You can simplify this a little bit and say half plus 1 is 1 plus 2, which is 3 by 2 over 3 by 2 plus x to the power minus half plus 1 is half over minus half plus 1 is again half plus the constant c. Now that we can simplify this a little bit by saying this 2. Now this 2 is in denominator's denominator. That can go in the numerator. So that will become 2x to the power 3 by 2 over 3. That 2 can go in the numerator because it's the denominator's denominator. Plus similarly this 2 can go in the numerator, x to the power half plus c, and that's the result that we are looking for. All right, that's the last question of this exercise. Uh, they frame it a little different here. They say derivative of f of x is this function. Now we know if derivative of f of x is this, integral of this function is nothing but f of x. In other words, simply just integrate both the sides. In order to start solving this, integrate both sides. Since we want to find f of x in the end, we want to get rid of this derivative. To get rid of that derivative, just integrate both the sides, because the derivative and integral will end up cancelling each other. So if you integrate, so you get integral of d by dx fx dx equals integral of 4x cube minus 3 over x to the power 4 dx. Okay, now since you are integrating on both sides, also add a constant c. Whenever you integrate, just add a constant term c. Okay, now that integral and that derivative will kind of cancel each other out. So you are left with just f of x equals, because that integral and that derivative will end up cancelling each other out. So this term, that integral and derivative will kind of cancel each other out, and you are just left with f of x. Okay, now let's just split that integral in both the terms here. So we get integral of 4x cube dx minus integral of 3 over x to the power 4 dx plus that constant c. I hope it makes sense so far. We integrate both the sides to get rid of that d by dx because we want to find f of x in the end. Okay, now take that constant 4 out and take that constant 3 out. So we get 4 integral of x cube dx minus 3 integral of 1 over x to the power 4 dx plus c. Okay, so you take those constants out, then now you can integrate here directly x to the power 3, but this 1 over x to the power 4, by the laws of indices, you know this 1 to the power 1 over x to the power 4 is nothing but x to the power minus 4 by law of indices. So you can also integrate that directly. So you are left with 4 integral of x to the power 3 is x to the power 4 divided by 4, okay, minus 3. Now for that x to the power minus 4, that can be written, the integral is x to the power minus 4 plus 1 over minus 4 plus 1, because that's just like x to the power n. Okay, so minus 4 plus 1 over minus 4 plus 1 plus that constant of integration c. Now that 4 and 4 will get cancelled, right? Also, that can be then written as x to the power 4. This minus 4 plus 1 is minus 3, right? So that's minus 3 x to the power. That's also minus 4 plus 1 is minus 3 over minus 3 plus constant of integration c. Okay, now that 3 and 3 will also get cancelled, and that negative and negative will become positive. So you are left with x to the power 4 plus x to the power minus 3 plus constant of integration c. That's your function of x. Now, does that complete the question? They say find f of x, but they also have one given condition. F of 2 is equal to 0. Whenever they give such a condition, they always give this to find your arbitrary constant c. Such a condition is always given. The reason is to find your arbitrary constant c, they give this extra given thing to you, that f of 2 is 0. So if we want to find f of x, we already have f of x here. We already saw that f of x is this term, x to the power 4 plus x to the power minus 3 plus that constant of integration c. Now, we don't want this constant of integration c. We want the exact value of that constant. In order to find that exact value, they have this given condition here, which is f of 2 is equal to 0. Okay, now we can use this condition here. So let's see. Let's say f of, now since we know f of 2 is equal to 0, they have given that f of 2 is 0. That means instead of x, they're telling to substitute us 2. So let's say, let's find f of 2. So f of 2 is equal to, here, substitute 2. So f of 2 is 2 to the power 4 plus 2 to the power minus 3 plus c. Okay, I hope that makes sense. So you just substitute x is equal to 2 here because we know f of 2 is 0. Now we know this LHS, f of 2 is 0. So you can say 0 equal to 2 to the power 4. So we know 2 to the power 4 is 2 times 2 times 2 times 2, which is 16, plus this 2 to the power minus 3 can be written as 1 over 2 to the power 3 plus c. Now this 2 to the power 3 is nothing but 8. So 0 equal to 16 plus 1 over 8 plus that constant c. Okay, I hope that makes sense so far. So from here, can we say c is equal to, that c is equal to, you can just take those two terms on the left hand side and you get minus 16 minus 1 over 8. You get minus 16 minus 1 over 8. Okay, so you can simplify this by saying 16 times 8. So 16 times 8 is 128. So you get minus 128 minus 1 over 8. Okay, so you can just do cross multiply. 16 times 8, which is 128, minus 1 over 8 is minus 129 over 8. So that's the value of c. C is minus 129 over 8. Now since you found c, we can just substitute that c in your function f of x. So eventually we get f of x is equal to, so your final result is f of x is equal to x to the power 4 here plus x to the power minus 3, x to the power 4 plus x to the power minus 3 plus c, which is minus 129 over 8. That's your function that we are looking for. You can simply also write x to the power minus 3 to simplify it further as 1 over x to the power 3 minus 129 over 8. Now that's the answer of f of x that we are looking for. Remember that whenever they give that condition like this, f of 2 is equal to 0, this condition is always given to find that constant of integration c. Okay, so we first integrate both sides. Uh, we integrate both sides and find f of x. Then we use that given condition f of 2 is equal to 0 to find the value of c. And then you substitute that value of c in your original function f of x in order to get the final result, which is what we got here. Okay. If you have any questions at all, please feel free to put it in the comment box. Feel free to reach out to me if you have any questions. I'm more than happy to help and support you. Okay. Thank you very much.